Hello students, welcome to Breedmark Academy. Myself L.S. Nanda. Now in today's video, I am going to discuss the solutions of two mathematics questions that were asked in recently held JEE Advanced 2025 Paper 2 exam. Now this is the first question of this video. This question is based on the topic of probability. It says a factory has a total of 3 manufacturing units M1, M2 and M3 which produce bulbs independent of each other. The units M1, M2 and M3 produce bulbs in the ratio 2:2:1 respectively. It is known that 20% of the bulbs produced in the factory are defective. It is also known that of all the bulbs produced by M1, 15% are defective. Suppose that if a randomly chosen bulb produced in the factory is found to be defective, the probability that it was produced by M2 is 2/5. If a bulb is chosen randomly from the bulbs produced by M3, then the probability that it is defective is. Now students, it's an interesting question, and to solve this problem, I will use two theorems. The first one is Bayes theorem and the second is total probability theorem. Now first of all, let's define all the events. The first event which I am defining is M1, which says a bulb is produced by manufacturing unit M1. Now similarly, the second event is M2, which says a bulb is produced by manufacturing unit M2. And the third event is M3, which says a bulb is produced by manufacturing unit M3. Now students, we move further. Now students, we define the last event, and that is D, which says a bulb chosen at random is found to be defective. Now in the question, it is given that bulbs produced by manufacturing units M1, M2 and M3 are in the ratio 2:2:1. So this clearly means probability of M1 is equal to 2 upon 2 plus 2 plus 1, which is 2/5. Similarly, probability of M2 is equal to 2/5 and probability of M3 is equal to 1/5. And then we are given that 20% of the bulbs produced by this factory are defective. So that means probability of D is equal to 20/100, which is further equal to 1/5. We are also given that 15% of the bulbs produced by manufacturing unit M1 are defective. That means probability of D by M1 is equal to 15/100, which is further equal to 3/20. And lastly, we are given that if a bulb chosen at a random is found to be defective, then the probability that it has been manufactured by M2 is 2/5. So that means probability of M2 by D is equal to 2/5. Now students, by using Bayes theorem, I will write the expression for PM2 by D, and this becomes equal to PM2 into P D by M2 whole divided upon probability of D. Right? Now there is no need to write the expanded form of PD, just write probability of D, because we are given the values of probability of D and probability of M2 and and probability of M2 by D. So from this equation, we can easily find the value of probability of D by M2. Now students, we move further. Now students, when we put the given values in this equation, we get 2 upon 5 equal to 2 upon 5 into probability of D by M2 whole divided by 1 upon 5. And now we get probability of D by M2 equal to 1 upon 5. Now students, I will use total probability theorem to write the expression for probability of D, which is equal to probability of M1 into probability of D by M1 plus probability of M2 into probability of D by M2 plus probability of M3 into probability of D by M3. And now we know that probability of D is 1 upon 5. Probability of M1 is 2 upon 5. Probability of D by M1 is given as 3 upon 20. Probability of M2 is 2 upon 5 again. Probability of D by M2 we have just found, it is 1 upon 5. Probability of M3 is 1 upon 5 and probability of D by M3 I am supposing as X, which we have to find. Right? So now we have got a linear equation in terms of X. Now we'll solve this equation and get the value of X. Now students, this equation can further be written as 1 upon 5 minus 3 upon 50 minus 2 upon 25 equal to X upon 5. Now just take the LCM of the denominators on the left hand side of this equation. It comes as 50 and in the numerator we get 10 minus 3 minus 4 and this is further equal to X upon 5. So when we do the calculations we get the value of X as 3 upon 10, which is further equal to 0.30. So this is the correct answer of this question. Now students, we move towards the next question. Now students, this is the next question. This question is based on the topic of vectors. It says, consider the vectors x equal to I plus 2j plus 3k, y equal to 2i plus 3j plus k, and z equal to 3i plus j plus 2k. For two distinct positive real numbers, alpha and beta, define capital X vector equal to alpha into x plus beta into y minus z. Capital Y vector equal to alpha into y plus beta into z minus x, and capital Z vector equal to alpha into z plus beta into x minus y. If the vectors capital X, capital Y and capital Z lie in a plane, then the value of alpha plus beta minus 3 is. Now students, in this question, it is given that these three vectors, capital X, capital Y and capital Z, they lie in the same plane. That means they are coplanar. So the scalar triple product of these three vectors must be 0. Right? Now students, let's find capital X vector. This is equal to alpha into x, which means alpha into I plus 2j plus 3k. Then we have plus beta into y, which means beta into 2i plus 3j plus k. And then we have minus z, which is minus inside the bracket 3i plus j plus 2k. Now students, this can be written as alpha plus 2 beta minus 3 inside the bracket into I plus inside the bracket 2 alpha plus 3 beta minus 1 into j outside the bracket plus k into inside the bracket 3 alpha plus beta minus 2 bracket closed. Now students, similarly we will find capital Y vector and capital Z vector, and then we will find their scalar triple product and put it equal to 0. Now students, capital Y vector is equal to alpha y plus beta z minus x. So it becomes alpha into inside the bracket 2i plus 3j plus k bracket closed plus beta into inside the bracket 3i plus j plus 2k bracket closed minus inside the bracket I plus 2j plus 3k. This can further be written as I into inside the bracket 2 alpha plus 3 beta minus 1 plus j into inside the bracket 3 alpha plus beta minus 2 plus k into inside the bracket alpha plus 2 beta minus 3. Now students, we find capital Z vector. This is equal to alpha z plus beta x minus y. So this becomes alpha into inside the bracket 3i plus j plus 2k bracket closed plus beta into inside the bracket I plus 2j plus 3k bracket closed minus inside the bracket 2i plus 3j plus k. Now this can further be written as I into inside the bracket 3 alpha plus beta minus 2 bracket closed plus j into inside the bracket alpha plus 2 beta minus 3 plus k into inside the bracket 2 alpha plus 3 beta minus 1. Now students, we will find the STP of capital X, capital Y and capital Z vector and put it equal to 0. Now we move further. Now students, the STP of capital X, capital Y and capital Z vector is given by the determinant. In the first row, the elements are alpha plus 2 beta minus 3. Then we have 2 alpha plus 3 beta minus 1. Then we have 3 alpha plus beta minus 2. In the second row, we have 2 alpha plus 3 beta minus 1. Then 3 alpha plus beta minus 2. And then we have alpha plus 2 beta minus 3. In the third row, we have 3 alpha plus beta minus 2. Then we have alpha plus 2 beta minus 3. And then we have 2 alpha plus 3 beta minus 1. Now the value of this determinant is equal to 0. Now students, to simplify this determinant, I am doing an operation, and that is C1 tends to C1 plus C2 plus C3. So now this determinant becomes In the first column, now we have 6 alpha plus 6 beta minus 6. Again, here also we have 6 alpha plus 6 beta minus 6. And the last element of the first column is also 6 alpha plus 6 beta minus 6. And rest of the elements are same as before. Now students, you can clearly see we can take out 6 alpha plus 6 beta minus 6 common from the first element. And now in the first column, we will have 1, 1, 1 as the elements. Now it will become easier to solve this determinant. Now students, we get 6 times alpha plus beta minus 1 inside the bracket into determinant. In the first column, we have 3 ones, and in the second column, we have 2 alpha plus 3 beta minus 1. Then we have 3 alpha plus beta minus 2. Then we have alpha plus 2 beta minus 3. In the third column, we have 3 alpha plus beta minus 2. Then we have alpha plus 2 beta minus 3. And last element is 2 alpha plus 3 beta minus 1. Now students, we will create 0 at this place as well as 0 at this place. For this purpose, I will do the operation R1 tending to R1 minus R3 and R2 tending to R2 minus R3. Right? Now, one possibility is that the value of alpha plus beta is equal to 1. Right? And another possibility is that the value of this entire determinant is equal to 0. Now let's find the value of this determinant and put it equal to 0. Now students, after performing these operations, we get 0 over here and 0 over here. Here it is 1. And at A12 position, we get alpha plus beta plus 2. At A22 position, we get 2 alpha minus beta plus 1. And here it is same as before, alpha plus 2 beta minus 3. Now here we get alpha minus 2 beta minus 1. Here we get minus alpha minus beta minus 2. And here it is 2 alpha plus 3 beta minus 1. Now students, we will expand this determinant along the first column. Now students, upon expansion of this determinant, we get minus alpha plus beta plus 2 whole square minus inside the bracket 2 alpha minus beta plus 1 into inside another bracket alpha minus 2 beta minus 1, and this is equal to 0. Now this can further be written as alpha plus beta plus 2 whole square plus inside the bracket 2 alpha minus beta plus 1 into inside another bracket alpha minus 2 beta minus 1, and this is equal to 0. Now students, just open up the brackets by applying suitable identities and you get 3 times inside the bracket alpha square plus beta square minus alpha beta plus beta plus 1, and this quantity is equal to 0. Now students, the expression inside the bracket can further be written as alpha minus beta upon 2 whole square plus 3 beta square by 4 plus alpha plus beta plus 1. Now students, since alpha and beta are distinct positive real numbers, so this particular expression, since it is the square of a real number, so this is always greater than or equal to 0. This quantity will be certainly greater than 0, and the quantity alpha plus beta plus 1 will certainly be greater than 1. So the sum of all of these terms cannot be equal to 0. So hence this particular possibility is ruled out. So now we are just left with one possibility, and that is alpha plus beta is equal to 1. So that means the value of alpha plus beta minus 3 is equal to minus 2. So this is the correct answer of this question. Now students, I have created two playlists of paper 1 and paper 2 for JEE Advanced 2025 Maths paper solutions. So you can go to the playlist section of my channel and watch all of these videos. So keep watching my videos and enhance your knowledge of mathematics. Thanks.